Hello everyone. So this is the part 2 of solid state chemistry CSIR net PYQs. So let's get started. Okay. Now the first question is, the metallic gold crystallizes in FCC structure with unit cell dimension of 4 angstrom. Okay. The atomic radius of the gold is, now see, A is given 4 angstrom. ठीक है, we know that for FCC the relation is 4r under root 2a. So they are asking about the atomic radius. So basically we have to find r, right? So r will be under root 2 by 4a. So it will be under root 2 by 4 into 4 angstrom. Cancel, this is root 2, which is 1.414. So the correct answer will be 2. Clear? Now next question, it's an important question. An element exists in two crystallographic modifications with FCC and BCC structures. The ratio of the density of FCC and BCC modification in terms of the volumes of FCC and BCC. Okay, see, we know that the formula for the density is this, you have to remember. Okay, Z mass Avogadro number into volume. Okay, now we know that for BCC the value of Z is 2 mass Avogadro number volume of BCC, right? For FCC it is 4 mass Avogadro number volume of FCC. Now divide both the equations. D BCC, density of BCC upon density of FCC. Now see, this will cancel out. Okay, this is 2. So you will get here BCC FCC, you will get 2 upon volume FCC. So it's FCC 2 volume BCC, right? So they have asked of FCC and BCC, just density of FC. Okay, first just inverse it. FCC over density of BCC, it will be 2 volume BCC over volume FCC. So the correct answer will be 2. Okay, now the question number 3rd. A solid consisting of only X atoms has closed pack structure. Closed pack structure means CCP. It is also known as FCC. Assuming it to be closed pack structure of hard sphere with radius equal to half of XX bond length, the number of atoms in 1 centimeter cube. Very easy. Here basically you have to calculate the volume of FCC first, then you have to tell how many atoms are present in 1 centimeter cube. Okay, for FCC the relation is 4r under root 2a. Okay, now the XX distance means this one है ना. So r मतलब 2r value is given 160 picometer. ठीक है, you can calculate the value of A from here है ना, because r will be 80 picometer. Okay, so under root 2a is equal to 4 into 80. A will be 4 into 80 picometer convert into centimeter divided by root 2, right? So this will be your edge length. Now we know that volume is A cube. Okay, now you have to cube this value. Firstly you will calculate this A from here, it will come, if we multiply and divide by root 2. Okay, so it will come 2 root 2 into 80 into 10 raised to power minus 10, 160 root 2 into 10 raised to power minus 10 centimeter. So volume we have to cube this one. Okay, so you will get volume equal to 160 root 2 into 10 raised to power minus 10 the whole cube. Okay, on solving this you will get the answer. You can solve it. Okay, centimeter cube. Now see, we know that in FCC the value of Z is 4. Okay, the number of atoms per unit cell in FCC is 4. So 4 atoms are present in this much volume. You have to apply unitary method. Okay, they are asking in 1 centimeter cube, it will be 4 divided by this. Okay, now you can calculate it easily. The answer will be 3.45 into 10 raised to power 23. So the correct answer will be 2, right? Then the next question is the interplanar spacing of this plane in cubic unit cell with lattice pattern. See, in a cubic we know that D is A divided by h square plus k square plus l square, right? A they have given, now h square plus l square plus 0. This is 4.242 2 root, right? So it will be 4.242 1.414. Now it is if we it is cutting into three parts, 3 right, 3 Armstrong. So D will be 3 Armstrong, 3 through 3, approximately this 4 will be the right answer, 2.45. Now fifth question, in a compound AXBY has a cubic structure with A atoms occupying all the corners. Corners means 8, contribution is 1 by 8, as well as the face center, 6 faces, and contribution is 1 by 2. The B atom occupy 4 tetrahedral voids. 4 tetrahedral voids. So here B will be 4. This is Y. Okay. So 4 tetrahedral voids. So the answer will be 3. A4, B4. AB will be the 4, 4. Okay. The value X 4, 4. See, in this mainly why I have taken this value 4, you have to remember that tetrahedral voids are those voids in which the atoms are present at the center of a, like, see, if there is a cube, है ना, if we divide the cube into 8 parts, 4 front, 4 backward, the center will form that tetrahedral void. Okay, octahedral void, 1 body center and plus edge center. These are the position for the octahedral void. Now sixth question, the coordination number of C in this whose structure is correlated to that of, this is calcium fluoride. Okay, now we know that in calcium fluoride, this is fluoride structure. Okay, calcium, it occupies all the FCC position, and fluoride, this is positive part, this is negative part, right? Fluoride occupies the all the tetrahedral void, and the coordination number of calcium is 8 while that of fluoride is 4. This you have to remember. Now if we correlate B2C3 with this, now this will occupy tetrahedral void and its coordination number will be 4. So the correct answer will be 2, right? Here BE will occupy the FCC points. Now the next question is the correct relationship among the following for a tetragonal crystal system is. See, obviously a sin theta is given, matlab Bragg's law is used. We know that according to Bragg's law, 2d sin theta is equal to n lambda. Here we are using value of n, that is first order, so 2d sine theta lambda. Okay, now here sine square theta na, so sine square theta will be lambda square upon 4d square. Now we know that the value of d है ना, d is the interplanar distance, 1 by d square is equal to h square upon a square, k square upon b square, l square upon c square, right? Now we know that in this 2 are equal and 1 is not equal है ना, so we will assume a is equal to b, okay, and c is not. So here we'll get this a square plus l square upon c square, so 1 upon d square. So we'll put this value over here, or you can further solve it like 1 upon a square c square will be equal to c square h square upon plus k square plus a square l square, right? Now when you put the value over here and then you will solve it, sine square theta will become h square 4d d square. Now you will write this one full value, a square c square h square plus k square plus a square l square. Okay, so the correct answer will be 2. Now the next question, a compound A consists of atoms A and B. B forms cubic close packing lattice and the atom A occupies half of the octahedral and half of the tetrahedral. Now see, B forms cubic close packing, मतलब 4 Z value, we know that 4 for FCC, and A occupies half of the octet. Now here octahedral void will be 4, tetrahedral void will be 2 into 4 8. So A occupies half of the octahedral void, 4 by 2, plus half of the tetrahedral void. Now it will be 6 B 4, so it will be A3 B2 when we will simplify this. So the correct answer will be 2, right? Okay, 9th, plutonium, whose we are given with atomic mass 24 gram per mole, crystallize in monoclinic lattice. Okay, the dimensions are given, A this much, B 480 picometer and C 1100 picometer with angle of 120 degree. Here Z is 16 atoms per unit cell. The density will be close. Now see, density same formula we'll use, Zm Na volume. Now the volume, you have to remember this, of monoclinic lattice is ABC sine beta. Okay, so just you have to instead of V you have to write this, so the density will become Zm Na ABC sine beta, right? Z here 16, mass is given 24, the value of Avogadro number is 6.022 into 10 raised to power 23 into ABC. You have to multiply everything. Now you know you have to convert this into centimeter. This is picometer. Why? We know that 1 picometer is equal to 10 raised to power minus 10 centimeter into 10 raised to power 10 the cube. Okay, centimeter. And sine beta, it is given 0.98. Now upon solving this you'll get 20.25, here 26, so fourth will be the right answer, right? Okay, 10th question, the number of cationic vacancies per mole when NaCl is doped with this much mole percent of BCl3. Now see, we are doping, NaCl is doped with this much 10 raised to power Na mole percent of BCl3. This much mole percentage means this much moles of BCl3, मतलब 10 raised to power minus 5 moles of BCl3. Okay, when this NaCl is dropped with Na moles of BCl3. Now see, when we are replacing one NaCl with one BCl3, now Na positive and B is having plus 3 charge. We are replacing one charge with 3 positive charge. So here 2 cationic vacancies are created, right? Similarly, if we replace like this much moles of BCl3, you have to see how much vacancies are created. We know that for this much moles of BCl, moles means this much atoms of 23 atoms of BCl3. Now for 1, 2 cationic vacancies are created. Okay, for this much you have to multiply it by 2, you will get the answer. So 2 into 10 raised to power minus 5 into 23. So on solving this, you will get 12.046 in 10 raised to power 18. This much. So 2 is the right answer. So atom wise you have to see, here they are given with moles. Now you have to convert into atom. We know that 1 mole is equal to Avogadro number of atoms. Na value you know, 6.022 into 10 raised to power 23. Okay, now the next question is, Cu crystallize in face centered cubic lattice. Considering each Cu copper atom has a hard sphere and is in contact with its nearest neighbor, the fraction of the volume of the unit cell occupied by C. This is very simple question, because see, FCC, we know that the value of packing fraction is 74%. So this is a direct one-liner question, right? Now we'll discuss 5 questions from the Bragg's law that came in CSIR net in previous 10 to 15 years. Now the angle at which, in the Bragg's law, you have to consider just one formula, 2d sine theta is equal to n lambda. By utilizing this formula, you will get the answer of each and every question. See, the angle at which first order Bragg's reflection is observed, n is equal to 1, first order, HKL plane is 110. In a simple cubic unit cell of A is given 3.238 Armstrong. When chromium radiation, you have to find the wavelength is given, when the chromium radiation of wavelength 2.298 Armstrong, wavelength is given, A is given, you have to find the angle, that is you have to find the sine theta value. Very easy. See, firstly you have to evaluate D. You know that the formula of D is A h square k square upon L square, right? So while evaluating, you will get 2, you have to put there in this. The A is this much, h square, this will become root 2 sine theta 1, and lambda is 2.29. Okay, upon solving everything, you get sine theta is equal to 1 by 2. Obviously at theta 30 degree, sine theta is 1 by 2, so the answer will be 1, right? Now moving on to the next question. In each question same concept is used. Here the unit length is given 40 nanometer. Again first order diffraction angle you have to calculate. Achha, here angle is given, okay, HKL is this one, angle how much, 30 degree. So what you have to calculate, the value of the wavelength of X-ray used. Simple, you'll use the formula 2d sin theta is equal to n lambda 2 d, same formula you will use, this one, 40 upon 2 square 1 square 0 square, sin 30 is 1 by 2 and 1, and you have to calculate the lambda. ठीक है. Now see, the unit of this is nanometer, so whatever answer you'll get, lambda will be in nanometer. Now solving this is 40 upon root 5 है ना. So the answer will come approximately 18 nanometer. This you can solve. Now third question is, in a simple cubic lattice the ratio between the unit cell length and the separation of two adjacent crystal planes cannot have the value of. Okay, now simple, they are considering a simple cubic lattice है ना. For a simple cubic lattice we know that the value of D, because they are asking about two adjacent parallel crystal plane separation, so D is basically interplanar distance, ठीक है, is equal to A h square k square L square, right. Now the ratio between unit cell length, A is the unit cell length and D is the separation, so ratio between A and D will be HKL square, this one, okay. Now they cannot have the value, okay, so in this you have to see है ना which value is not possible. Now starting from first 5 is possible if we take H2 K1 and L0, 5 is possible, root 5, okay, so this is possible. 7, now 7 how you will see, if we'll take 2 है ना, 4 2 4 5 6 no 7, root 7 is not possible for any integer value of HKL, so the answer will be 2, but let's also explore other options. 11 is like 3 square 9 10 11 हाँ 3 1 1, for this it is possible. 13, if we'll take 3 9 2 square 4, 9 plus 4 13 and 0, so for this it is possible, so the correct answer will be 2, right. Then fourth is, metallic crystal exhibits peak corresponding to the Miller indexes, this one, in its powder XRD pattern, it is crystallized in the okay, so here you have to use a concept that for a simple cubic, for any value of HKL is possible, any value, ठीक है. For BCC their sum should be even, for FCC HKL either all even or odd, this you have to see, okay. Now see, in this 3 4 3 even one is not possible, so it will be mostly simple है ना, for any value, so it will be primitive cubic, any value of HKL, ठीक है, because these are not possible all. For the now the last question, first reflection in the powdered X-ray diffraction pattern of a cubic crystal arises from this 1 1 1, ठीक है, same question, same concept will use, you have to keep these rules in your mind, ठीक है. This see, this is all odd, ठीक है, तो and also So this follows this FCC, but also it also follows simple cubic because any value of HKL. So but the answer is 1, but I think some more values of Miller indexes should be given. So fourth can be the correct answer, but in the answer key the answer is 1. So you have to take the preference whether firstly you should go for FCC or BCC, then at last you can go for the simple cubic. You can check for the simple cubic. Okay, so this was the part 2 of solid state chemistry. Now there is just one part left, then we will be done with all the previous year questions that came from this topic. I hope you enjoyed the session. If you are having any doubt, do let me know in the comment section. Thank you.